Before you embark on your learning journey, it's a good idea to learn how you can navigate through the course interface and make the best use of the available features. When you access a module, you'll first view the landing page, which displays its title and the content structure. You can begin the module by clicking the Start Module button. This takes you to the first lesson. You can also view the content structure for each module in the left panel. Each module is divided into sections, and each section consists of lessons. You can also navigate to any lesson by clicking the lesson title in the menu. Note that you can go through the lessons in any order, and you can revisit them at any point. Keep in mind that to complete a lesson, you must scroll all the way down until you see the button that indicates the title of the next lesson. You can check your progress of the module at 2 levels. If you're looking for a specific topic, you can use the search feature. Videos are played using a custom smart player, which provides several features. The Captions button enables you to switch off or display the captions in one of the available languages. You can also customize the way captions are displayed by clicking on the caption settings. From here, you can increase or decrease the font size of the captions and even choose between different colors and transparency levels for the caption's text and background. If you prefer a faster or slower playback speed, you can change it in player settings. To navigate to other modules in the course, you click the Previous or Next buttons. You can also click the View Full Path button to view all of the modules available in the course. To complete a course, you must complete all of the modules that are marked Required. You're now ready to expand your learning horizons at UiPath Academy. Happy learning! Hi, welcome to the UiPath Production Ready Essentials training. Today, we'll cover the basics of selectors in UiPath Studio. We'll start with a brief definition of the concept, and then we'll move on to an example to illustrate how selectors work. What are selectors and how are they created? Selectors are properties of UI automation activities. They contain the attributes of each graphical user interface element and its parents as XML fragments. Selectors are generated automatically every time we use an activity that interacts with graphical user interface elements. Let's move on to an example. We'll use a click activity and indicate the first name field in the MyCRM application. Aside from the informative screenshot, the selected area is identified through the unique selector, which can be viewed in the Properties panel or in the UI Explorer window. Let's examine the attributes of our selector. The GUI element that we clicked on is included in the last line of the selector. All the previous lines are the parents of that element. The first line is usually referred to as a root node, as it locates the top window of the application. In the UI Explorer window, we can navigate the UI hierarchy tree by clicking the arrows in front of each node to expand or hide the corresponding section. This is how each line in the XML fragment is mapped on the application interface. The XML fragment that makes up the selector contains tags and attributes. Attributes enable us to interact with the UI elements at a specific level of the selected application. Although selectors are generated automatically, they might require some fine-tuning at times to work effectively. Let's quickly go over the cases in which selector adjustments are necessary in order for the workflow to be executed seamlessly. Firstly, some web pages generate dynamic IDs for the elements they comprise. To illustrate that, we'll use UI Explorer to retrieve a selector from the RPA Challenge web page. We'll indicate the company name field. The element ID is displayed on the last line. However, if we try to refresh the web page and then validate the selector, we can notice that it becomes invalid. As a result, we need to indicate the element again. The value of the ID attribute changes every time we refresh the page, so it cannot be used reliably to identify the field every time the automation project is executed. Secondly, the generated selectors might be too specific. Picture a case in which we need to interact with multiple similar elements. We'll consider the example of two PDF invoices. Let's open UI Explorer and indicate the first one. We can notice that the name of the PDF file is stored in the title attribute. When we select the second file, the selector changes as well, because the file name is different. As a result, the selector needs to be changed to enable the processing of both invoices alike. Moving on, selectors must also be adjusted when automating applications that are prone to system changes. For instance, if the version or name of an application changes, the selector attributes have to be adjusted in such a way as to identify different versions. Furthermore, some selectors contain an attribute named IDX. This attribute is the index that the current element has within its container, which includes multiple similar elements. It is recommended to replace the IDX attribute with a more reliable one in order for the item to be detected even if the web page is updated and the indices become different. Let's return to the RPA Challenge web page to demonstrate this. We'll click Indicate Element and then select the company name field. If we remove the ID, the IDX attribute is displayed instead. Now we can highlight the element to make sure that it's the one that we clicked on. And everything's fine so far. But what happens if we refresh the web page without updating the selector? We can notice that a different field is highlighted this time because the order of the fields has changed. In such cases, the IDX attribute is unreliable. Okay, that concludes our demo. Stay tuned for the next lessons to find out more about selectors in UiPath Studio. Goodbye! Hello, and welcome back to the RPA Developer Production Ready Essentials training. Now that we've learned what selectors are, how they're generated, and how they work, we can proceed to a more in-depth demo of the UI Explorer wizard, which is one of the most frequently used tools in UiPath Studio. Now, in the previous lesson, we discussed some automation scenarios in which the selectors generated by the UI interaction activities might not be reliable in the long run. Now, today, we'll see how we can adjust the automatically generated selector attributes to ensure that our selectors are stable and adaptable to any possible system change. We've already created a new project, so let's open the UI Explorer wizard. We'll attempt to identify the first name field in the My CRM application. Let's click the Indicate Elements option and select the field that we're interested in. Now, we can not only see the automatically generated selector of the input field, but also the entire visual tree of the application that we're automating, with all its nested containers. Moreover, we have the option to check whether the generated selector corresponds to the correct field by clicking the Highlight button here. The UI tree also has a highlight option, which can be enabled by clicking here. If we browse through the containers below, the UI elements of the application are highlighted as we're clicking them. The central panel displays the position of the input field within the UI hierarchy. Each line displayed here is called a node. The first node corresponds with the application itself, and the next ones match the different nested containers. The element that we selected is defined by the final node. If the selector does not identify the correct element, we can try to switch to a different UI framework by clicking this button and selecting one of the three options that are displayed. Afterwards, we need to indicate the element again in order for the selector to be updated. Now we can try out all the options and pick the one that returns the most accurate selector. In the selector editor window, we can see the raw selector, as well as the optimized one below. Usually, optimized selectors consist of the first and the last nodes, which are enough to identify an element within the page in most cases. The raw selector can be extremely intricate, but we can freely enable or disable the nodes in the hierarchy if needed. To make sure that an element is successfully found, we can make the selector more specific by increasing the number of nodes included in the refined selector. And the final selector is a standard XML fragment containing the various node types and their attributes. Node types indicate the type of control the node points to, while attributes help identify the elements on the page. Most of the time, when selector errors are thrown, we need to edit the attributes and match their values to the ones in the application that we want to automate. If the two values are not identical, the elements fail to be recognized. And we can also check or uncheck the attributes in the raw selector to make it more specific or generic, depending on the case. Let's test what happens when we enable the text attribute and use the selector in an activity. To do that, without generating a new selector in that activity, we can copy this one here. Next, we'll drag a Type Into activity to the Designer panel and go to the Selector field in the Properties panel, where we can simply paste the selector as a string. We can see that it was automatically recognized and converted. Let's type a name, say Diana. And now we can run the workflow. Okay, well the value was entered in the field after the already existing one. If we don't want that to happen, we can go back to the Properties panel and enable the Empty Field option. Okay, let's try to run the workflow again. But we'll change the value to be entered in the first name field to a different one, Alex. Okay, we're all set. And the execution failed this time. Now that happened because our selector includes the text attribute, which has the Oscar value. That's an example of a selector that is too specific and only works in a particular case. Moving on, let's take another look at the selector editor window. It is similar to UI Explorer, but only includes two panels. The first one contains a list of all the attributes of the nodes that form the selector, and the second one displays the used selector. The current selector is invalid. To fix it, we can deselect the text attribute and click the Validate button. Now it looks fine. To open the entire attribute list, we can click this button here to open UI Explorer. And that was all for today. Thank you for watching. Hello, and welcome back to the RPA Production Ready Essentials training. Today, we'll continue our lesson on UI Explorer by discussing the functionality of Property Explorer panel and taking a look at an example of when it is useful. Let's begin. A part of UI Explorer that is often overlooked is the Property Explorer panel. The Property Explorer panel displays all the available attributes of the currently selected element. We'll go to the RPA Challenge website to indicate a UI element, such as the phone number label. After making the selection, we can see that all the available attributes of the element are listed here. The panel on the right side of the screen only displays the selected attributes, but the Property Explorer section shows all the possible attributes of the selector corresponding to the UI element we selected, including inner HTML, inner text, the position and role, and so on. In some cases, the access to the attributes here can turn out to be very useful. In UiPath Studio, there are multiple activities that use selector attributes. For example, the getAttribute activity retrieves the value of a specific attribute, which can help us build the subsequent workflow logic. In web applications, we can also set the value of an attribute. Now that can be useful in cases such as attended automation. Let's consider the example of the RPA Challenge website. Using the setWebAttribute activity, we could disable the Submit button or change the text it displays to guide the users throughout their interaction with the robot. Let's build an example workflow that includes the WaitAttribute activity. When we use it, the robot pauses the execution until an attribute has a specific value. Let's indicate the Start button. Here is the generated selector, which is valid and reliable. It does not use the AA name attribute, which is fine. As before, the Property Explorer window displays all the available attributes such as type, visibility, whether the element has focus or is in the foreground, and so on. Let's go back to the website. When we click the Start button, the value changes to round 1. Our selector is still valid and indicates the previously selected button when we highlight the element. When we indicate the element again, we can notice that the value of the AA name attribute was updated in the Property Editor panel, the same as the inner HTML and the inner text. Let's say that we want an attended robot to wait until the label of the button changes to round 1, and then to highlight the button. Let's refresh the page. Next, we'll search for the Find Element activity and indicate the Start button again. The generated selector is a reliable one. We'll save the identified element in a new variable called button. We'll then proceed by adding a WaitAttribute activity to the Designer panel. The input element is the variable that we have just created. The attribute list was automatically compiled, so we can simply select the one that we want. Next, we'll type round 1. The activity has a 30-second timeout, so if the element is not identified within that time frame, an exception is thrown. Let's add a write-line activity to showcase when the robot is waiting during the execution. Let's type waiting for button press. Next, we'll use a highlight activity and provide the button variable in the element field. OK, now when we run the workflow, we can see that the outline panel displays the text. We'll go to the RPA Challenge web page and click Start. The text changed, so the button was highlighted and the execution stopped. This approach is useful in automation scenarios where we need to check the state of certain UI elements or retrieve information about them. And that was all for today. Thank you for watching. Hello! Welcome back to the UiPath Production Ready Essentials training. Now that we've worked a bit with selectors, we can move on in our learning journey to selector types. More specifically, we'll focus on the distinction between full and partial selectors. Full selectors contain all the information required to identify a specific UI element. They also include the top-level window, as opposed to partial selectors, as we'll see later on. The activities that have full selectors are not included in container activities, such as attach window or attach browser. Moreover, the basic recorder generates full selectors. Now, it's recommended to use full selectors when the robot must switch between multiple windows while performing the automation workflow. Partial selectors are enclosed in containers such as attach browser or attach window, which store the information related to the top-level window. As a result, partial selectors do not include that information. Their usage is recommended in projects that automate multiple actions in the same window. Let's take a look at an example. We'll use a click activity to select one of the elements in the demo MyCRM application, such as the active checkbox here. Let's open the selector editor window. Now we can see that the first line in the generated selector identifies the application, so this is a full selector. The lines below are used to identify the element inside the application window. Moving on. Let's also generate a partial selector to see the differences between them. As mentioned before, we need a container application, namely attach window. Now, before adding the click activity, we need to indicate the window that the robot must work in. Now we can go ahead and add the click in the Do section of attach browser. The selector of the click activity is not complete. It only contains the last part. Its first part is inherited from the container activity. Let's quickly look at an example of typing into the first name and last name fields. First, using the basic recording wizard and then the desktop one. We'll create a new sequence and start with the basic recorder. Let's change the first name to Jim and clear the fields beforehand. We'll change the last name to Young. Now, let's perform the exact same steps, but this time using the desktop recorder. If we have a look at the resulting workflows, we can see that the basic recorder generated two type into activities that have full selectors. As for the desktop recorder, it generated an attach window container. The activities inside it have partial selectors. Moving on, we'll go over one last example of what partial and full selectors look like, but this time we'll consider the case of web automation. Let's start a new sequence. Now we'll use the Open Browser activity and paste the go.uipath.com address. We'll use a click activity to select one of the elements on the web page, such as the search box here. Let's also use a click outside the Open Browser container to compare the two selectors. In the first case, our selector is a partial one. In the second one, the selector is full. And that concludes our lesson on selector types. Thank you for watching, and until next time, happy automation! Hello and welcome back to the UiPath Production Ready Essentials training. In the previous lessons, we've learned what selectors are, how they're generated, and when they might require fine-tuning to work effectively. We'll proceed to some of the most common ways to repair selectors, to make sure that the correct UI elements are identified in as many automation scenarios as possible. We'll start by creating a workflow that removes the double spaces in a Notepad document using some UI interaction activities, which generate selectors, as we already know. Afterwards, we'll fine-tune the selectors that identify the application in such a way as to make our workflow applicable to multiple Notepad files. We'll use this file here. Let's add a sequence to the Designer panel and rename it to Sequence Notepad. We'll also add a short workflow description as an annotation. Moving on, let's search for an Attach Window activity and indicate our Notepad file. We'll also change the name of the activity to follow the best practices. Now, to remove the double spaces in the text file, we'll use the Replace command, whose shortcut is Ctrl+H. We can automate that action in Studio using the Send hotkey activity. Now the robot must fill in the fields in this pop-up window, so we'll add two Type Into activities. Since we need to find all the double spaces, the string that we'll enter in the first field consists of two spaces, which must be placed between quotation marks. The second Type Into activity will instruct our robot to enter a single space in the Replace With field. And now we can move on to a click activity to select the Replace All button. After performing all of those steps, we can close the pop-up window using one more click activity. We'll save and run our workflow to see how the execution goes. Alright, it works. But what if we want to remove the double spaces in a different file? Well, let's try that out. We'll simply close this file and open a different one. And run the workflow again. This time, the selector was not found. Let's take a closer look at the selectors to see what's wrong and try to repair them. We can notice that the title attribute comprises the name of the previous file. Let's click the Repair button and select the new Notepad file. If we look at the selector now, we can see that the first two characters in the title were replaced by an asterisk. This illustrates the use of selectors with wildcards. An asterisk replaces several characters, while a question mark replaces a single one. The workflow is executed successfully this time. Now, let's see what happens when we open the third file, which has an entirely different name. The title of the previous two files were similar, and the selector wildcard only replaced the two characters that differed from one file to the other. As a result, the value of the selector attribute still contains a part of the file name. Let's open the Selector Editor menu to make some adjustments. Instead of clicking Repair, as we did before, we can edit the attribute manually. In this case, we can remove the timestamp altogether. And the selector is valid, so let's click OK and run the workflow. And it worked! And that was all for today. In the next tutorial, we'll automate an application and learn how to create dynamic selectors. Stay tuned. Hello and welcome back to the UiPath Production Ready Essentials training. Our previous tutorial detailed the usage of selectors with wildcards. Today, we'll move on to dynamic selectors. We'll understand when dynamic selectors are needed and we'll learn how we can create them in UiPath Studio. Let's begin. We'll build a workflow that collects data from an Excel file and enters it in the AnyTeller application. In each case, the robot must select one of the 3 radio buttons, depending on the value in the Use Cache Count column. We'll go ahead and create a new sequence called AnyTeller. Before adding any activity, let's leave an annotation that describes our workflow. The first part of the process consists of reading the information in the Excel file. We need a read range activity, so let's search for it in the Activities panel. We'll browse for the file and clear the range field to retrieve the entire sheet. Let's store the collected data in a variable called input data. Next, the information should be entered in the AnyTeller application, so we'll use an attach window activity. Let's indicate the window and rename the activity to attach window AnyTeller. Now, since we want a series of operations to be repeated for each processed row, our next step is to add a for each row activity. The data type is row, and the variable that contains the items is input data. Now, to be able to select one of the 3 radio buttons, first we have to enable the Use Cache Count option. We'll drag and drop a check activity to the Designer panel and indicate the checkbox. Let's also rename the activity. Moving on, we need to select the radio button that has the value indicated in the spreadsheet. We'll create a new variable called Count option and set its value using an assign activity. In the To field, we must type an expression that extracts the value in the Excel column and turns it into a string. So, the rows we'll extract are in the Use Cache Count column, and the extracted data should be converted to string. We'll use another check activity and indicate one of the items in the Use Cache Count section, say Use Amount. Now, let's take a look at the selector and adjust some attributes to make sure that any of the 3 radio buttons can be checked. This is what the selector looks like in the editor window, but we'll open it in UI Explorer. The first 3 nodes contain attributes whose values change every time a different radio button is selected. So, let's go ahead and uncheck them to widen the scope of our selector. It is valid, so we can close this window. Now the name attribute indicates a specific radio button. To fix that, we can use the count option variable, which holds the values of all the radio buttons. To use the variable, we can simply choose the attribute and hit Ctrl+S. We'll select the variable and click OK. Now that we've set the attribute value to a variable, our selector is dynamic. As a result, it can uniquely identify a UI element at runtime, according to the value of the variable. Let's rename the activity, as always. The next actions that should be performed are typing into the 3 fields and then clicking OK. We'll add the activities to the Designer panel. The first one is for the Cache In field, so let's indicate it. Let's not forget to rename the activity. The value can be found in the rows of the Cache In column in Excel. We'll use the toString method to convert the extracted values. And let's repeat the steps in the second Type Into activity. We'll indicate the OnUsCheck field, rename the activity, and type the expression in the value field. It is almost identical to the first one, as only the column name is different. Let's also set up the third activity. It should type in the Not On Us check field, which we'll indicate now. Next, let's change the activity name and type the expression. We've arrived to the final activity, which is a click. All we need to do is indicate the Accept button. And we'll change the name of the activity to Click Accept, and we can save the workflow. Before running the workflow, let's deselect every checkbox and make sure that the Excel file is closed. OK, We can click Run. The values in the 3 fields and the selected checkbox are changing. And it's done! In this tutorial, we created a selector that contains a variable, namely this one, which stored a value extracted from an Excel file and enabled the selection of the corresponding checkbox. In the next video, we'll go over an example of fine-tuning selectors in web automation. See you soon! Hello, and welcome back to the UiPath Production Ready Essentials training. This is our final demo about selector fine-tuning. Today, we'll build a web automation workflow that extracts data from the Acme website. Now, we don't need the entire table here. Instead, we'll only read the number in the Work Item ID column. Let's start this new project by adding a sequence to the Designer panel. As always, we'll change the name and add a description to make sure that the purpose of the workflow is visible from the very beginning. Obtaining the Work Item ID from the Acme web page. The selectors that we generated in the previous 2 tutorials were partial because we used the Attach window activity. Today, we'll continue working with partial selectors, but we'll use Attach Browser instead. Let's indicate the browser window. Next, we want to avoid using the screen scraping wizard to attain the information in the table, so we'll use a getText activity. We can indicate any item, say this one. Let's also rename the activity. Moving on, we'll have a look at the generated selector. We can notice 2 attributes, the table column and the table row. Let's open this selector in UI Explorer. If we click Indicate on screen again, but we select a different ID, such as the first one, we can see that the value of the row attribute changes and becomes 2. If we point to the last element in the list, the value changes once again. For now, we'll save the selector as it is. Now let's create a new variable called index of the integer type. Now, the first cell that contains a work item ID is in the second row, so we can set a default variable value of 2. We'll open the selector again to use this variable as the value of the table row attribute. Let's click it and hit Ctrl plus space, which enables us to select the variable, and click OK. Now we've just created a dynamic selector that has a default value. Next, we'll add a while loop after the Attach Browser activity. There are 12 rows in our table, so let's type the condition index in lower than 12. We can simply drag the getText activity and drop it in the body section. We'll create a variable to store each item. Let's call it text. In the end, we'll write the work item ID value to the output panel using a log message activity. And the message is work item ID, followed by a colon and the text variable. Just before running the workflow, let's make sure that the value of the index variable increases after each execution of the loop. We'll use an assign activity and type index +1 in the value field. And let's rename the activity to assign increment. And we can click Save and run the workflow. All right, the output panel now contains all the work item IDs, so the dynamic selector that we created earlier works successfully. And that concludes our tutorial series about the ways of fine-tuning selectors. Thank you for watching, and until next time, happy automation! Hello and welcome back to the RPA Production Ready Essentials training. Selectors are one of the core features of UiPath Studio. However, they may be a bit challenging to understand when starting out. One of the difficulties relates to the fact that selectors should be specific and generic at the same time. To be more precise, selectors should be specific enough to uniquely identify interface elements, but also generic enough to work even if there are a few changes on the screen. Now in today's lesson, we'll focus on those difficult situations in which reliable selectors are not automatically identified in Studio. For our demo, we'll be using the input fields from the RPA Challenge website. A simple workflow has already been created, and for this exercise, we want to highlight the first name text box on the landing page. To make sure that we have a good enough selector, the robot will loop through highlighting the first name text box and clicking submit 5 times. So, how can we tell that our selectors aren't good enough? In UI Explorer, we click on Indicate Element and proceed by selecting the first name text box. Now the selector generated by this activity uses a tag and an ID to identify the element. The clue that the selector might not be good enough is the generated ID, which cannot be read by a human, as it doesn't mean anything. Generally, when we see an ID like this, it's probably dynamically generated, so it changes every time that the web page refreshes. Now there are a few different ways to tackle this problem. Let's proceed by detailing some of them. We'll use the same example for all approaches, in which we highlight the first name text box and click the Submit button 5 times on the RPA Challenge website. Let's start our demo by using the anchor base activity. Now it's important to understand how the anchor base activity works. The anchor sets a starting point on the screen, the center of the selected element, and it will look for a match in the specified direction. For our example, we need an anchor and the element relative to it. We'll use the Find Element activity and indicate the first name label on the website. This will serve as anchor base. Because we want to highlight the text box, we'll drag a highlight activity next to our anchor and reduce the highlighting time to half a second. We hit save and run the main workflow. And there it is, it works. We had 5 highlights on the correct element. To conclude, using the anchor base activity is one way to tackle the situation of not getting reliable selectors. A different method involves creating a relative selector using UI Explorer. Now we begin by indicating the input field on the screen, which, in our case, is first name text box, and then we select the first name label as our anchor. The selector that we get is not good enough because it still contains the automatically generated dynamic ID, which is not useful. We proceed by validating the selector, and we can see that it is indeed valid and ready to be used for the highlight activity. Inside the relative selector workflow, we drag a highlight activity and, on the right-hand side, we paste the selector that we have constructed earlier. We hit save and go back to the main.xaml, invoke the relative selector workflow, and run it. As you can see, it works. This concludes the second option of creating a relative selector using UI Explorer. Now, let's explore a third method called Visual Tree Method. In UI Explorer, we go back to Indicate Element and select the first name text box. The following method requires some investigation in the UI tree. We can see that the input field is under a div container, together with label. Inside the div container, we proceed by selecting the input field, where the entire UI tree is showcased. From this point on, we need to activate our target input field, and therefore we click on the parent container and remove the CSS selector from the right-hand side. This will result into getting a good enough selector for our activity. We now need to remove the element ID, which is not good enough. So we deselect it from the right-hand side. We also need to make sure that the identifier for our container is good, which seems to be the case for our example. We proceed by copying the selector and validating it. So we copy the selector and paste it in the target selector on the right-hand side. Rename the highlight activity to highlight first name input field and hit save. We proceed by returning to the main workflow and invoke the visual tree method XAML. We run the workflow, and as you can see, it works. Now this showcases a third possible way in which we can improve the selector by configuring a better path in the UI tree. So, to summarize, we've seen 3 methods in which we can get a good selector and solve the problem of identifying the elements on screen. Unfortunately, in some rare cases, these 3 methods are not enough, and we need to do something even more specific. Let's take a look at how we can use the activity called Find Children. The aim using this method is to target a reliable container so that the Find Children activity will return all of the child UI elements of that particular container. We begin by creating a new sequence named Find Children. We also drag the Find Children activity and in UI Explorer, click on Indicate Element and select the first name text box. We proceed by clicking on the div container and then highlight, and we'll notice that it highlights both first name label and text box. We go ahead and copy the selector that we currently have and return to UiPath Studio, where we indicate on screen the first name label. We proceed with selecting the first name label and then change the selector by pasting the one that we've saved earlier. The output of this activity is a collection of all the UI children that are identified according to the scope defined. We'll proceed with creating a new variable, which we're going to call children, and change the scope from find children to find_descendants. In this way, the activity will iterate through the nested containers, so that if we were to have another container inside the parent container, and the input field some levels deeper, we could still find it. With the Find Children activity, we'd only get the top level. The children variable is a collection of UI elements, and we'll iterate through it, making use of the for each activity. We'll call the iterator element. The type argument will be changed to UI element, and for the variable expression, we type in children. If we were to save and run the workflow, it will result in not only highlighting the first name text box, but also the first name label. So we need to identify the input field that we're interested in. In this case, we'll use the name of the element to figure out if it's the input field that we're interested in. We type in an if statement, hit save and run it once to see if it's done correctly. And it works. We return to the main workflow, invoke the Find Children XAML, and hit run. This will result into highlighting the first name text box for 5 times. To sum everything up, we've seen 3 ways of dealing with difficult selectors, either by making use of the anchor base activity or by creating a relative selector or improving the selector tree. We've also gone through the Find Children activity and made an iteration through all of the UI elements, identifying the one that we were interested in. This being said, we conclude today's lesson. Thank you for watching.